going.
Alrighty, so on your notebooks, we're going to be looking at completing the square. And let me just kind of give you an idea about what this is about. When we're looking at the forms of a quadratic, we have three forms of quadratic. There's the ax squared plus bx plus c, which is your general form. We want to salute that one. We have our y equals a times x minus p times, x minus q, which is our intercept form. Am I falling off? I am. I'm falling off the table. Sweet. Okay, how's that? Are we still in the picture?
Yep.
All right, our last form would be the vertex form, and that's the big kahuna. All right, and I hope I have that right. A equals x minus h quantity squared plus k. Okay, what we're trying to do with completing the square is taking a quadratic in this general form and converting it into the vertex form. Okay, it's easy to graph a quadratic in vertex form. It's not quite as easy to graph it in general form. Okay, and so this is going to help us to find our vertex and make it easier to graph. Not to mention, this idea of completing the square is how we come up with the actual quadratic equation itself. Okay, so first things first. We're going to look at, let's just jump in. We're going to start with the example. We're on page 1. We're looking at the x squared, y equals x squared plus the 8x plus the 10. Now, some of you have never used algebra tiles, but you're going to see these little pictures in your book. And I'm going to kind of tell you what that is there. You're going to see something like this, and there's going to be a little part down there. Are you with me? This part here is considered the x squared tile because one side is x long and the other side is x long. So the whole area that it takes up is x squared. Is that making sense? Yeah. All right. Tiles like this are considered x's, okay, because they're 1 in width, but they're x in length, okay? This would be considered an x, and this would be a constant, all right? So one thing you do when you're completing the square is you want to take half of whatever your middle term is. What's half of 8x?
4x.
4x. So I'm going to put 4x down here, and I'm going to put 4x over here, okay? Now, the length of this puppy right here is x long, because this is x by x, this is an x squared, okay? Now, the length of this one is x long, so how long does it make this here if this is 4x?
2?
4 times x is
4x.
So, that's all right.
Yeah.
It's all right. You've never, you probably, if you haven't seen algebra tiles, then this is going to be new to you. Yeah. Okay? All right. So, this length here is x, right? This is something, and this area is 4x, so this up here is going to be 4. Are you with me on that? All right. Remember when we were doing that box multiplication before, when we had those binomials and we were multiplying them into the box? Okay, well, x times x gives me x squared. X times 4 gives me 4x. Okay? X times 4 gives me 4x. What is 4 times 4?
16.
16. That's what's going to go here. Okay? Now, do I have a 16? No. Oh, now, there's a fundamental rule of algebra. Well, it's one of our major properties. It's called the additive identity. It is always okay to add 0. So that's what we're going to do. But we're going to make 0 look really pretty to help us out. Okay, so here we go. We're going to take this puppy right here. We've got y equals x squared plus 8x plus, what would make this look nice for us? 16
over 16? No, that'd be 1.
0 over 16?
No. Sorry, I'm not making myself clear. Plus 16, if we were to complete the square, we'd get to write a perfect square like this.
Oh.
Right? See this shape made a square? This side is x plus 4 long, this side is x plus 4 long. Okay? So to have x plus 4, it's going to look like x squared plus 8x plus 16. Right? But what was it really?
X squared
it was
plus 10.
Plus 10, right? So I'm putting my plus 10 over there because that's what it really was. And right now I'm just totally illegal because I added 16. That's not legal, so what do I have to do? I have to take away 16. This is all one long equation. Work with me here. Just hang on.
Okay.
Don't freak. I'm freaking. Okay. We're going to put this in parentheses. Okay? And we're going to factor that. Well, we already know it's x plus 4 times x plus 4, because that's what it means to complete the square, right? So we can write it as y equals x plus 4 quantity squared. And what am I left with on the outside here?
Plus
Plus
10
10
minus
minus 6 or
16.
negative 6.
Okay, let's just say minus 6.
Okay.
Sweet. Now, does this look like this? Why, yes, teacher, it does. Yay! We just converted standard form into vertex form by completing the square. Now you're thinking, how did I do that? We're going to do it again and again and again until you get it.
I feel like it just got unblindfolded.
Okay. So what we're going to do is I want you to see that this is the same thing, so I want you to type them into your calculator.
Okay.
All right? So in your calculator, first one I want you to put in is the x squared plus 8x plus 10. Okay? And put that in y1. Okay. And we'll have to look at a good window. I don't know if you'll be able to see much with Zoom 6. Do you see anything? Probably not. Maybe?
I had Zoom 6 is
Is it giving you anything?
a fairly good window.
Is it a good? Yeah. Okay. So now in Y2, type in this puppy, but walk over this way. Remember how you get the circle tail thing?
Yeah.
That's what we want to do. And we should find that our graphs are identical, and one covers the other exactly.
You have low battery on this.
Is that what it's
so-
saying? Okay, pause me.
Okay.